G'day, Alacar J here, and in this video we're finally going to put together all these scripts and things that we've been working on and output some complex noise to generate some height maps with. Now I'm just going to go ahead and start setting a scene up, explain what I'm going to do, and then start punching out a script to see how you can use the Perlin module and some filters to generate some outputs. So I'll just say this is a new scene. And we'll take that script off. We just want the quad to start with. I'll position that. So what I'm going to do here is, as we have done before, we're going to generate a sample of Perlin noise. We're going to create a texture and apply it to this renderer. And then we're going to run that same noise through a filter, and then we're going to output that texture onto this renderer. So we can see like a before and an after filter. And later on I'll introduce some more. Let's start at the beginning. So this will be our, let's just call it quad before. So that will be our Perlin noise output before filter, and our quad after. We have before and after. Let's create a script that will generate some noise. Yeah, filter example. And so we'll start off by creating an enum of all our filters, so that then we can choose that from the inspector, what filter we're going to apply, and then run a switch case based on that enum value. I'll have a public enum. This will be our single filter. And we can apply none. What else do we have? We have turbulence. We have exponential. We have the simplified exponential, which is the flatten. Now made a diamond square smooth. And just so we can see how it works, we'll add the flip axes. Okay, so there's an enum of all our different single noise filter types. So for our noise sample, let's create a class to store all the variables for that noise sample in. So we want to see it in the inspector, so that'll be system.serializable public class noise sample. And what were the variables? Well, first we need to create, we're going to keep track of our noise array. And our Perlin module takes in frequency. Octave and lacunarity, persistence, and our offset. So if I remember correctly, those are all the variables that our Perlin module will take. So then we want to output that noise that we generate using all those parameters onto our renderer. So we have our public renderer, And that was our quad before. And then we're going to apply that noise to a filter. We're going to modify that noise, and we're going to return the modified noise, and we'll make another texture to show what it looks like after it's been set through a filter. So let's create a variable for what filter we're going to apply. And there are a couple of parameters in our filters. Like there was one where we had it all for our smoothing, and for our flattening they had iterations. What else did we have? We had the exponential, we had a public float for sharpness, and that was in a range between 0 and 1. And we also had our power factor. I could also include the other one we had. Oh no, it's cover. My mistake. Trying to do this off the top of my head. The cover changes how much darkness or light it had, and the power factor was how dense it was. And the sharpness affected it way too much. So after we apply our filter, we have our second renderer, our quad after, so we can see what effect the filter had. And I'm ignoring if I'll have the grayscale for the texture or not. I don't know if that's going to work. Alright, so let's set up our noise. So there's one value that we didn't have, and what is the size of this array? So this will apply to all our noise arrays, so we'll just make a single variable here. Give it a header. That'll be an integer. And then we need a variable that will store this class that we can apply all these values to. So that's a noise sample, isn't it? Our public noise sample. I'm just going to call it noise 1 for now, because I am going to add a second noise, and then we'll use a blend filter to blend the two different noise samples together. So after that, we're not going to have the outputs. Let's start off with that before I go too far ahead. So same thing. We don't need a wake at all. So I'll start. We'll say generate. And our update will say if input get mouse button down generate. So we better create that function generate. So because we're going to have more than one sample, I may as well create a function that will take in the noise sample, do all the calculations, and apply the outputs to the renderers in that function. So let's do that. Let's go generate noise sample, and we'll pass it our noise 1. Better create that function. Okay, so we'll pass that into our noise sample, and here's where we can do all our calculations. So to start off, I'm going to create and set our Perlin module variables. I'll say a Perlin module equals new Perlin module with all the parameters. So we'll pass it our size, pass in our sample frequency, our sample octaves, our sample taking X offset, sample linearity, and finally our sample persistence. So there we created our Perlin module. Then we want to generate the noise. So our sample dot noise array equals our Perlin module dot get noise map. And that will return our 2D array of floats. So we generated this. Okay, so we'll apply we'll display our before filter noise. Let's just check if we have a renderer. If we have that, our sample before material main texture equals, I did include the use grayscale, so we'll use a ternary operator here, and we'll check our sample use grayscale. Get texture with our sample dot noise. Now we'll return a grayscale texture. Then our sample noise, and we'll also get our gradient. Through gradient. And that will close that off. Okay. So now we want to apply a filter to our noise that we generated. As I said before, we'll do a switch based on our sample, what did I call it? Our single filter. And we'll create a case for each single filter type. I'll just set up the structure of the switch case first. I had turbulence, exponential, flatten, smooth, and flip axes. Okay, so here we can call the functions on our new utility script tools filter. So I'll pass in our noise to each function and return our float. So we can say here our sample noise equals utils filter. This one will be for the turbulence, and we're sending in our sample noise. Exponential, and we have the optional parameters there. That's what I was thinking. See, color. I am going to have to put sharpness in. Because that's an optional parameter, but we can't assign a value to this one and just say to use the default one here. All your default ones have to be at the end. So we'll say our sample cover, our sample sharpness, sample power factor. Okay, so this filter is flatten, so our sample noise equals flatten. This will take in our noise and our iterations. Did I not include iterations? Ah. Our smoothing is the same. Copy that out. Smooth our noise by the number of times we set. Our flip axes is just simply passing the noise into the filter with no other parameters. And default, we won't do anything. Okay, so based on the filter that we assign in the inspector, it'll run the function, pass in our noise, and return our modified noise after the filtering. And then let's apply it again to the texture just like we did before. So after filter noise. And instead of quad before, we got our quad after. Okay, so that was a little bit intense, but we're just getting started. So we have our quad before, quad after. Let's create an empty game object that will hold our filter example script. And you see here as I apply it, it's already given our noise. We've got our class here that we can see. Alright, since it did override the grayscale, let's put in some generic default values. So our frequency equals 1F. Our octaves equals 4. Our linearity equals 2F. Our persistence equals 0.5. And our offset okay, so our cover equals 0.5. 0.65, sharpness 0.95, same for our power factor, 0.95, iterations, okay. Oh, I've missed an F somewhere. Float, float, float. Okay, so again, this will be our filter example. We'll apply that script, and it has already set in the default values in the inspector. That's great. Okay, so we have our quad before. So let's name this quad 1. This one quad 1. So this is our quad 1 before. Now quad 1. Oh, my mouse is gone. Okay, so let's just save the scene, hit play, see what's happening here. As before, we're generating our noise, bring up our frequency, hit the mouse, and you see there's no filter being applied. So the output, the before, the after, is the same as the before. So if we change to our turbulence filter, you can see our turbulence filter being applied. Add our exponential filter, you can see the exponential filter being applied. So let's have a look at these two new ones. So flatten, like I said, it's a more harsh version of exponential. So I've changed that to 2. See, it's starting to get dark there. See, it's starting to get really dark there. So you really don't need many iterations on the flatten. But as I said, it's just a simplified version of an exponential filter. But it does give a different output. Something to play with. And what was the other one? Smoothing. Our diamond square smoothing. I don't know if you can see that. See how that has become more blurred? And again, if we bring up the iterations, it's really starting to smooth that out. So there's a smooth filter. And finally, the flip axes. Like I said, there's a weirdness with Unity's terrain system being flipped on the X and the Y. So we've got the same noise. We bring the frequency back to 1. And the octaves to 1, so we get a real basic noise. Can't really see it, can you? So there we see the X and the Y being flipped around. Great. So we have a good example there of our noise before and applying a filter and seeing what it looks like after. Okay, now that we set up one before and after scenario, let's set up another before and after scenario and play with that a little bit more with a blend filter. So I need to duplicate these two and bring it down here. This will be our quad 2 before and our quad 2 after. Let's make that. Okay, we've got 2 samples. Let's go back to the script. We'll copy this out. So this is our noise sample 1. Now this is our noise sample 2. Our noise 2. So now we have 2 noise samples in our generate. We better pass the second one. It's that function we created. See, so instead of typing all that out again, we can just pass that through, create our Perlin module, get our noise from it, apply it to the before, apply the filter, and apply the noise after. Let's have a look at that. Filter example. Now we've got 2 classes here. We better add in our renderers. Something weird going on my drag. Definitely something weird going on with my drag. Yeah, my mouse is on its way out. Oh boy. Okay, come on, mouse, work with me here. No. Yay, we finally got in. Let's save that before my mouse dies again and I can't put them back. So let's put all these quads as a child of that. Let's tidy it up a bit. Okay, so if we hit play, now they're getting the same thing. So if we up the frequency on this one, see it's happening, and just say that one was an exponential filter, this one was a turbulent filter. So we're generating two samples of noise, okay? So now we'll have a look at applying these two noise samples through a filter, a blend filter, blending the two together and giving one final output. So let's create some more variables. So this will be our noise blend output. And we're going to have a public renderer. Let's just call it quad output. Then we need to make another enum for our blend filters. So let's do that. A public enum. This will be a blend filter. And we have a type of blend add. And we have a filter for blend multiply. So now we have that enum, we can say which one we're going to apply. And then one of our blend additive has a bias. So we can finally see how all this stuff works. And the same with our grayscale. So let's create another function after we've gotten both our noise samples. We're going to generate our noise output. Better create a function for that. So because we're going to be blending these two together, we're going to be storing that in a new array. We don't have an array set up here, so we can just create one locally. We'll say our float array which is our noise output, equals new float. And because we're using the one size, we can use the size. And then because we've got different blend filters, to do another switch of our output filter. Our blend filter. Do a switch on our blend filter. The case for each type. Okay, so at our blend add, then our noise output array is going to equal utils filter blend add. We're taking our two floats and we're taking our bias. So this will be our noise. Our noise one. Noise, not great. Probably should have called it a noise sample up here. Oh well. So that's our noise one noise array, and then our noise two noise array, and our bias. What's happened there? Bias. Okay, for our blend multiply, we have a look at those parameters. We're just taking in the two noise arrays, not our bias. So multiplying one by the other. And when we've done all that, we want to do the same thing as we did before. Display our output blended noise. So if we have our quad output material texture equals just and so no, we'll be getting texture out of our noise output array. Okay. So now if we have a look, we have our two noise samples as before. We also have our extra parameters here. So let's create another quad. Our quad output. So we can see what's going on here. 0, 1, probably increase the scale. Why not? Let's see if my mouse wants to work. Oh boy. Yeah, my mouse button's dead, isn't it? Can I select it from here? Yes, we can. Let's save that. Put that back in there, make life a little bit easier. So let's see what we have. Let's just hit play. So we're blending two of the same noise samples. So what I must say, this one, we'll set the frequency right up. Give it a lot of turbulence. Actually put it through a turbulence filter. And for our second one, now let's bring the octaves right down for that one. Maybe not. Okay, so we have a high sample of noise here. We have a low sample of noise here. You see we're adding the two together to get this kind of output. Now, as I said before, modify the bias. So we'll give less of this and more of this. You can see that there. If we took that all the way down to 0, we just get 100% of that one. Same thing, we took that up to 1, we get 100% of that. So there's our blend add. Let's see what the blend multiply does. You see this has no factor here. So how can we use this to make some complex noise? Alright, if we take the second one and make that exponential, so there we go. We've got this noise, and we're using the exponential filter as a kind of mask to give out this kind of output, which would give pretty rough looking terrain. I'll give you very good examples here, aren't I? Let's play with some offsets. You see, this is being used as a filter, this one. Got this frequency right up. You're creating some islands with a few hills on it. Could be interesting. Or in this case, we've got a really high frequency. Let's just set that to nothing. We brought this down to a real low one. So hopefully there you can see the different kinds of outputs that you can generate. So that's about it. Haven't done a very good job of showing how this can be useful. Let's see if we can create something. Okay, so I said an exponential, you'd use it like a filter with your blend multiplier. So you see, if we made that one very high noise, see we created kind of like a, the values are really too low to show it. So if we took the smooth out, gave that none, does that give a better example? I think it does. So you see, no matter what happens to this noise here, this noise is acting as a mask. So even though we've got like a light area here, that's masked out there. So when we multiply it with that blend multiplier, that's still coming out as 0 in this region here. So this is essentially a mask. See, now we set the mask so it's over there. So all these white areas, it's going to allow a lot more of these to come through. So really the gradient's set a little bit too high, it's showing too much water. But basically this is it. This is a technique for using noise and filters to create more complex. As you can see, the only way of generating something that looks like a good terrain is just playing around with the values and seeing what you can come up with. And look far better than this bodgy color scale we're using if we applied this to a terrain. So I think I'll do that next. I'll set it up so that this noise output will actually get applied to a terrain so you can see it in 3D.